Alright, so for the investigation, we're going to just do question 1. This is for the take-home component. Let's do A first. Now you can graph this, where this is your X, this is your Y. The starting point was at 0, 3. Oh, what's happening here? There we go. Okay. The starting point is at 0, 3. We have 2 points there. We got 2 and -2, and then a point there and a point there. So just go down like this. This one there. Down like this. That's the other one there. Okay, that's A. Now let's look at B. So that's the starting point there. It's gonna go to this point there and then to the 0. So make sort of a figure 8 shape, and then it's very symmetrical. So it's back over there, then to number 3, like so, and back up there, and then we're gonna go to this point and then back up there, so you can see the direction as well. Okay. Now we got C. As you can tell, it's a straight line. Point there, 0, -7. And we'll end up at 3, 17. There we go. Alright. Then we just take a line. Now I would use a ruler and just draw that line in. Okay. And if you had graphed this on the class pad, it would have been going that way. For this next one here, you just need to get a few points. Starts at 0, -3, goes to there, goes to that one, goes to that one there, that one, and then it ends up at 6, 33. Alright. It's a nice curve just like that. Alright. So that's all question 1. Question 2, I've actually kind of shown you how to go from parametric form to Cartesian form. So we're going to use that now to sketch the motion, and then find the period, and then find the Cartesian equation. So the first one, circle of radius 4. I'm just going to pretend that's a circle. That's the final and initial point. Starts and ends at the same thing. Period is 2 pi. The Cartesian equation, once again, we've got x equals 4 sine t. Therefore sine t equals x over 4. Substitute this into this rule here. Okay, I'm going to use that one. We're going to get x over 4 squared plus y over 4 squared equals 1. Alright, so this is using sine squared theta plus cos squared theta equals 1. Okay. Now the only difference with this question here, exact same shape, a circle with a radius of 4, except it's going the other way around. Okay, the period is still 2 pi. Oops, the period is still 2 pi. In the Cartesian equation, we have all sine t equals negative x over 4, and cos t equals negative x over 4 with negative x over 4 squared plus negative y over 4. Sorry, that's a y there. Negative y over 4 squared equals 1. And you can simplify that. Okay. So question C. Can you graph it? It's actually going to start there at 0, 2. It's going to go through and it's going to hit 6. And back to 2. And back to 6. And then it's going to come around. It's going to go this way. Period like before, 2 pi. Cartesian equation, x over 6 squared plus y over 6 squared equals 1. Now we move on to something a little bit trickier. So with the equation, you're going to grab your turning points. There's a turning point there. There's a turning point there, and we'll just take 2, 2. We'll take that one. So we'll just go up like that, down and back up. That's going to go that way. We're going to start there. We got one path going here and the other path going that way. There's no period for that one. Leave that out. So we got y equals 2 sine 3t. We got x equals 2 sine t. And so we got 2 sine t, take 4 sine cubed t, and that's 2x minus 4x cubed. Check the trig rules on the first page on how I got that one there. Okay, question 3. Determine the domain. So all the possible values of t. There's a nice example there for you, so you can use that. Anyway, so we're going to take that one there. We've got 5, take t cubed. Well, t has to be real. Therefore 2 over 3. Therefore t can't be 3. And t has to be a real number. T can't be. So t can be all the real numbers except for 3. Alright. Let's look at second one there, 2 sine 3t. Well, for this one, t can be all our real numbers. But now let's look at the square root of t take 1. Well, t has to be greater than or equal to 1 because we can't have a negative of a square root. So t has to be greater than or equal to 1 and all the real numbers. Okay, going on to the next one. Question 4. determine the position when t equals 0 and when t equals 5. So when t equals 0, we have 5i plus 0j. When t equals 5, we have negative 4.33i plus 2.5j. If you left it in exact value, this is actually better. Right, you can leave that in an exact value. Ooh, at what time does the object first cross the vertical axis? In other words, what we got 5 cos pi over 6t equals 0, and that's when t equals 3. Okay, because this is x. Determine the magnitude and the position vector of at any time t. I'm going to basically find the magnitude of 5 cos pi over 6t squared plus 5 sine pi over 6t squared. You pop all that into your class pad and you get 5, which is your magnitude. Describe the path. Well, if you graph that in the class pad, here's what you would get. Here's what you would get. That would be your start. You would go across to a circle, come back around, come back to another circle. So in other words, it is a circle path, or a circular path with a radius of 5. It starts at 5, 0, travels anti-clockwise. Okay. Alright. So once again, direction of the vector to the positive direction when t equals 5. We have negative 5 root 3 over 2i plus 5 over 2j. Well, if you look at it in a diagram, that's what it's going to look like. Okay, that's your 5 root 3 over 2. This guy here is your 5 over 2. We want to find this angle here. So we just need to find that, and then we need to take it away from 180. Very simple SOHCAHTOA. And our angle is 150, or 5 pi over 6 radians. Ooh, the magnitude of R1. Very simple. So 5 cosine of pi over 6 plus 5 sine pi over 6. So 5 cosine pi over 6i plus 5 sine pi over 6j. Pop that into your calculator, get some exact values. Wait a minute, hold the phone, as they say. That's the same as our question C, so our magnitude is in fact 5. Easy money. Let's move on to question 5. Alright, so they should collide, these two paths. Let's prove. So to collide, have to equal. Let's find the time where they collide. So let's equal our i's Okay, so we have t plus 1 equals 7 take t. Simplifying that, we have 2t equals 6, and therefore we have t equals 3. Alright, now let's equal j. We have 2t equals to 2t squared over 3. We can cancel out those. We can get 0 equals t cubed, sorry, t squared over 3 minus 1 times t. So we're going to get t cubed over 3 take t. Solve that, ClassPad. ClassPad solve. T equals 0 and t equals 3. Hold on. Sorry guys, let's just cancel this out. So we have t equals t squared over 3, and that makes it 0 equals t squared over 3 take 3. Now pop that into the ClassPad and I'll solve, and I'll get this. Okay, sorry about that. Moving on to question 6. So we're going to find the intersection of these two paths. So once again, we have 7 take 4t equals 12 take 3t, negative 5 equals t. Then we got 13 take t equals t take 5. We got 18 take 2t. Sorry, 18 equals 2t, therefore 9 equals t. Pop that into your i's and j's and your r's and your s's. We have negative 21, 2. So how do we demonstrate when there is no collision between the two boats? Well, we have to find out when the x values are the same, what is their time? If we have the same x values at the same time, then there is a collision. So when are the x values the same? Okay, well, t equals negative 5. Well, t equals negative 5, and the y value t equals 9. Negative 5 and 9 are different times. No collision. Alright, so we're going to finish off with question 7. So there's a particle. A projectile is fired into the air from a cliff into the ocean, just like so. This is our equation for our projectile. Determine the height after 1 second. Well, obviously that's with t equals 1. R1 equals 45. Now what? The height. So we're only looking at the j component. Okay. Find the maximum height of the projectile. So you can use Fmax. This is just a ClassPad exercise. It's 65.918 meters. Time in seconds. T equals 3.061 seconds. Also from the ClassPad, determine when the projectile hits the ocean and how far from the base of the cliff this occurs. So y equals 0. T equals 6.729 seconds. So let's find our x value, and t equals 6.729. That's 201.87. So I'm going to substitute this into that. That's how I get 201.87 meters. Find the height of a projectile if its horizontal distance is 45 meters out from the cliff. So 45 equals 30t. That means t equals 1.5 seconds. Therefore, I'll put it into the y, 1.5. Put that into the class bed, I get 53.975 meters. That's all the questions on the take-home part of the investigation. Thank you.